Hey guys, my name is Jason with Mount Baker Mining and Metals, and on today's video we're going to be talking about matte and what it is in relation to gold smelting and why it's bad and why you want to get rid of it. When I started shooting this video 2 or 3 weeks ago, I thought it'd be relatively easy to make. I was going to smelt down some matte, recover a little bit of gold, get rid of the matte, and it'd all be easy. And that really couldn't be farther from the truth. So on today's video, I'm going to fumble my way through matte smelting and reprocessing to try and recover more precious metals. There are several experiments I do that don't work or don't work the way I want them to. And so I'm going to pop in and out a couple different times and kind of explain what's going on and what happened. And this is going to be probably part one of a multi-part series. So let's talk a little bit about what matte is. This is formed as an intermediate layer on your cone mold when you pour. And so typically on top you'll have your slag, and on the bottom you'll have precious metals, your collector metal, and then this matte is formed in the middle. And what this matte is, it's all the sulfides that are remaining in your charge that didn't get oxidized or decomposed in the correct way. And this is bad because even though it's mostly sulfides, some of your precious metals will be contained in this matte layer. And so the goal of every smelt or assay is to get just two phases, the slag layer and then your collector metal. If you have a matte phase, you kind of want to reevaluate what you did and try and get rid of this matte phase. There are a couple of common ways of getting rid of the matte or the sulfides in your ore. One is to oxidize them either by roasting in the open atmosphere. You heat them up to about 1,000 to 1,200 degrees Fahrenheit, and the oxygen in the atmosphere oxidizes and replaces the sulfur atoms that are on the molecule with the base metal and converts the metallic sulfides into metallic oxides, and then they can be absorbed into our slag. The other way is to oxidize these in the charge. And so you have your powdered sulfides in there, and you can add an oxidizer like potassium nitrate or sodium nitrate. And when those chemicals are heated in your furnace, they release a lot of oxygen, and it does the same thing as roasting, where it'll replace the sulfur atom on the base metal molecule with an oxygen atom, and you'll have that switch, and so you'll make sulfur dioxide and end up with a metallic oxide that is then soluble in your slag. The third way, and one of the ways that I think is most preferable for what I've been doing, is the iron soda method, where all your base metal sulfides, whether it's iron or copper or lead or any of these other base metals, the iron is much more reactive than those other base metals. And so when you put iron into your smelt, the iron actually pulls the sulfur off those base metal molecules, those base metal minerals, and it creates FeS. And so essentially you flood the system with metallic iron, which reduces all the metals that are less reactive than itself. And you guys can check out the metal reactivity series, I think it's called. Google it, and you can see all of the metals and how reactive they are compared to each other. But by adding the metallic iron, you pull all the sulfur off those less reactive base metals. You create a huge amount of FeS, just iron sulfide, and all the base metals get reduced to metallic form, and they go down and they collect in your collector metal at the bottom of your smelt and then in your cone mold. The unique thing about FeS is if you make your slag very basic by adding soda ash or lye, the slag will dissolve that FeS. You can get rid of it by using the right chemistry in the slag and the flux. So those are kind of the three common ways to get rid of it. But now let's talk about what we're going to do with this stuff and how we can get rid of it and reprocess it and see if there's any more precious metals left in our matte. And there's really two different characteristics. This is some matte that I did from a pretty large smelt here a couple of years ago. And it stayed nice and hard and solid for a long time, even in the moisture in the atmosphere and the air, the oxygen. So that's one type. And then there's this other type that either forms kind of black or brown, but as soon as it's exposed to the oxygen in the atmosphere or the water, it just collapses to powder. I mean, you put your little piece of mat in a dish or something, and you come back the next day, and it's just falling apart into this powder stuff. And so I'm going to try and screen out some of this powder and direct smelt it down and see if it's been oxidized by the water or the air. And maybe it's all oxides now, and it'll just direct smelt, and it'll be nice and easy. Our first job here is we're going to take our kind of powdered mat. We're going to screen it through a 50 mesh screen here and get the big chunks out. And then I'm going to try to just direct smelt this powder down and see if it's still sulfides or if they've been converted to oxides by the water in the air or the oxygen in the air when they sit out in the environment. Okay, here's our oversized stuff that was too big to go through the screen, obviously. And then here's our 50 mesh minus. So I'm going to take, I don't know, maybe 100 or 200 grams of this stuff, and we'll melt it down and see what we get just by melting it with our basic slag recipe. We won't use any iron in this first one. All right, here's our number 5 crucible. We got it filled up. I got 200 grams of the mat in here, 200 grams of borax, 200 grams of lye, and 100 grams of silica sand. That's our standard kind of flux recipe that I've been using. I've got a ton of other smelting videos out there on YouTube, so you can check those out for more info on the smelting. But we'll get this heated up, and we'll melt down our furnace, pour it into our cone mold, and see if we can get any precious metals in the bottom. And one more thing, I'm going to add about 30 grams of lead to this to act as a collector for any of those fine precious metals we might have. And there's our little bead from our first 200 grams of mat. And it's a little bit yellow, so it's probably in that 60 to 70% gold range. But that's what we lost from 200 grams of mat. 0.059 grams. And it's probably about half gold and half silver, maybe a little bit more gold. So we probably got 0.03 grams of gold and 0.03 grams of silver. All right, guys, here's our next test. This is a little bit different mat. This is all black. I've been saving this separate because this should have mostly lead mat in it. And I'm going to add the iron rod to this, hopefully, which is going to reduce the lead, either sulfide or oxide in here, back to lead metal, create that iron sulfide, and dissolve in the slag. So that little lead collector metal we got, I'm going to actually take it and I'm going to reuse it in the next smelt. And just reuse the collector metal and try and enrich it in gold and silver But first I want to try another little thing to see what's eating up our crucibles. All right, guys, well, we've had two just catastrophic failures of our crucibles here. And that's just no good. You don't want to do that. These were brand new crucibles, both of them. So now I'm going to take just a brand new crucible and run a blank. And I'm not going to put any sulfides in it, but I'll put our 200 grams of anhydrous borax, 200 grams of lye, and 100 grams of silica, and see if the crucible fails just with the flux, or if it's that we're processing matte and it's essentially pure sulfide and it's just eating up the crucible. So here's our crucible from our blank, and as you can see, it got eaten up real bad too. And so our flux is probably way too basic, and it's pulling a bunch of silica right out of the crucible here, and it's eating it up real bad. So we'll try clay graphite crucible and see if that works better. Because our fire clay crucibles are having so much trouble, I'm going to try this next one in a number 8 or number 10 graphite clay crucible and see if it holds up a little bit better. Well, there's our pour from our graphite crucible, and it looks like the crucible held up a lot better to those sulfides and oxides than the fire clay ones. So we'll let that cool down a little bit and knock it off there. I added iron again. That seemed to get rid of the matte on the second pour. And so hopefully we should have a lead button, slag on top, no matte, and good looking crucible. All right, now what I forgot to say in the video is up until this point, I've been dealing with that powdery fine stuff. The very first one we did, there was a little bit of matte, and we didn't use any iron, so that tells me that it's almost all oxidized. The second one we added iron and completely removed the matte altogether. We just had the slag and the lead button. And I forgot to say in the video that we used the really hard, competent matte for this one. And so this is a totally different characteristic of matte. And so it threw me for a little bit of a loop here. And this is kind of right where the video and the experiments kind of go off the rails. All right, here's our matte. And look at there, we got a bunch of matte in there. And it even looks like it, I don't know if it was too cold or what, but the matte kind of blurbed up into the slag there. It should be a nice flat surface interface between the slag and the matte. So that's pretty weird. And then here's our button. Bunch of matte there. Let's see if we even got any metal. Maybe all the lead was sucked up into the matte. And here's our last button from the graphite crucible. And I took the collector metal from the second smelt that we did and added it to the third one. So this is 2 collector metals worth. I added iron to both of them, and it's kind of hard to tell, but it looks like there might be little bits of copper and stuff in this button, so we might have a cupellation problem with all that copper, but let's get it in the furnace, get it warmed up, and see what happens. And here's a bunch of that oxide slag junk that was floating on top of our lead bead. And so I just pulled the cupel out of the furnace, scraped it off, and we can throw this in our next smelt and get it all oxidized and get it absorbed into our slag so we don't lose anything. But that's probably those base metals, those copper and some other junk that we had from the mat, and we got it all out of there. And now our lead's in the furnace, cupeling away. So here's our second button, and it's definitely yellow. So there's quite a bit of gold in this one, probably 70% or so, and just under half a gram. So at this point in the video, I'm still convinced that if I add enough iron, I can totally remove all the base metals from the mat and be left with FES, that iron sulfide mat. And my problem now is that my slag recipe isn't quite right, is what I'm thinking. And I just don't have enough slag, or it's not basic enough to absorb all that FES mat. And that actually turns out not to be the case. There's one other piece of information that I don't know yet, but I have come to realize since, is that copper mat or copper sulfide cannot be reduced by iron. Copper has a higher affinity for sulfur than iron does. So no matter how much iron you add to the mat, if there's copper in there, the copper will not reduce to copper metal. It will stay as a copper mat. So that's what I'm fighting at this point, but I don't realize it. All right, so now I'm going to try something that I've never done before. I was looking online, and the melting point of a lot of these, this different type of mat is right around 2,000 degrees Fahrenheit, 2,100 degrees Fahrenheit. So I'm going to try and just put some mat in a crucible and smelt it and see if I can get it molten without any flux, without anything else. And if I can get it molten, I'll put the steel or the iron right in there and see if I can reduce any metals directly out of molten mat and see how that goes. And here's our crucible loaded with the mat. I got the big chunks, and then I threw in all the powder. I saved out a few of the big chunks just because I didn't want to get it too full for an experiment, but we'll see if we can get this melted down and reduce any metal out of it that we can and pour it into our cone mold. For my iron, I'm going to try something a little bit different. These are little punches from the iron worker out in the shop, and they're just pieces of steel, but they're nice and small size, and so I can put a bunch of these in the crucible, and if there's any metal in the bottom, they should float in the metal, and right at that metal mat interface, and the mat can just eat them up and turn them into iron sulfide. So I'm going to try these and see how they go. I won't be able to pull them out like I do with the iron rod, but I'm just going to pour them kind of slow, and hopefully these will stay in the crucible after the pour, and all the metal and the mat will come out. But even if they do fall into the cone mold, it won't be a big deal. We'll just break them out when we break out the slag and see what we got from the cone mold, if any fall in there. All right, here's our mat, and it looks like we got a little bit of metal on the top there, so that's cool. But let me get this broken up a little bit, and we'll see what we got, see how much mat we got. Okay, here's our little bit of metal we got off of there. It's really, really white and brittle, so it's some mixture, alloy of probably base metals and hopefully some precious metals in there. Here's a little bit of mat that I knocked off, and I kind of picked through it with tweezers and stuff to try and get all the metal portion out. So now let's go look at our matte cone and see what that looks like. So here's our matte cone, and this here is the top. And there was a little bit of residual slag and stuff stuck to the pieces of matte, but you can see here's our point down here. This whole cone is all matte right there. Here's our cone of matte all broke apart. And here's probably the best example. Here's where the slag sits on top, that little thin layer of slag. And then here's the sides of the cone, and the bottom of the cone would have been right here. So You can see the mat there. And it's just a big, huge mass of FES mat at this point, which is kind of cool. I didn't realize it would all just melt down without any flux and stuff like that. So I'm glad I learned that. All right, I got our stuff here in this cupel. I'm going to add a bunch of lead to it. I'm actually going to reuse this one. This one still has quite a bit of capacity. So I'm going to put about 100 grams of lead in here and let this cupel all this sulfides and base metals away. And hopefully we end up with a little precious metal button there at the end. Well, look at there. There is a very gold-colored bead that we pulled out of our mat. Well, there's another gram of gold out of our mat, so I've got more work to do. Up until this point in the video, I've been doing some pretty shaky science. I haven't been mixing my material. I've been testing a whole bunch of different stuff and recovering more and more precious metals. So my next step is I'm going to take all of my mat, I'm going to crush it up, homogenize it, and then we can be working with the same material that's homogenized, and so we can get some really good numbers on the precious metal that's left in our mat. And so once I do that, I'm going to take a 100-gram sample of our homogenized mat, and I'm going to essentially assay it to see how much more precious metals are left in our stuff. All right, here's our mat. We're going to take it and run it through this little tiny jaw crusher. This is a little sample crusher. It's a 5-inch by 6-inch. Goes down into the sample tray here. And we'll try and crush up our mat and see if we can get it crushed up small enough to go through our little Beco grinder. We're going to do a little assay now, just to see if there's any more precious metals in there. And I have 100 grams here, so I'm going to mix twice as much flux as I normally do. I'm going to do 200 grams of anhydrous borax, 200 grams of lye, and 100 grams of silica sand. We'll smelt it and add a little lead for collector and see what we can get out of this mat. Okay, here's our metal out of our 100-gram assay sample. And I put in 25 grams of lead, and now the bead weighs 37 grams. So we recovered a heck of a lot more metal. It looks like there's quite a bit of copper in there. And so we're going to cupel this away and see what we get. And so here by accident, I've really kind of found out a way to counteract that copper sulfide by adding more lye to the smelt and also iron. And I think what happens is the copper sulfide turns into copper hydroxide, which is then actually reduced by the iron metal, which goes from iron metal to iron hydroxide and copper metal. And that collects down into our button, and that's why our lead button weighed so much more. And here's our little bead from that 100-gram sample we did after we recovered a gram of gold. So there's a significant amount of gold left in our mat. So at this point during the video, I'm pretty disappointed. I realize now that with the copper mat that we have, I'm not going to be able to just convert it all to iron sulfide and recover the precious metals. There's still precious metals locked up in those sulfides, and there's not going to be a really easy way to deal with it. So I'm going to stop it here for part one. We're going to pick up part two here in a couple weeks, hopefully. And my plan is to create a flux recipe that completely converts all of the copper mat into probably copper hydroxide, add the iron to reduce the copper hydroxide to copper metal, The slag should then absorb anything else in there, any other sulfides, and make them go away, so we won't have any matte. And we can completely reduce all that matte to metal, which we can then deal with in another way. And I've realized that the only way to recover all the precious metals is to reduce all that copper. And that's really going to be a pain because the copper does not cupel very well. And there's going to have to be another way that we deal with all this copper, because I have so much of this copper matte that I'm going to end up with probably hundreds of grams worth of copper. So my plan is I'm going to end up using the electrowinning process and remove all that copper by electrowinning, and the slimes from that will have all of our precious metals and any other base metals in there that I'll then come back, smelt again, and hopefully recover the remainder of our gold and silver. Hopefully you guys are enjoying learning with me about how to process this matte, and we can really start to understand why this matte is such a problem, because even though you are getting some precious metals collected in your button at the bottom, as long as you have that matte layer in between, you're going to end up with precious metals dissolved in that matte layer. And so that's why it's so important to deal with that matte on the very first go with your first smelt, and you're not having to reprocess matte or save it up. And that's why this testing is so important, doing 50 grams or 100 grams to get the recipe right, so that when you do end up with a big, 2 kilogram, 5 kilogram, 10 kilogram smelt, that it comes out right. You have slag on top, metal on the bottom, and you don't have 2 or 3 kilograms of matte you have to reprocess. So I hope you guys enjoyed the video. Stay tuned for our next one. If you have any questions or comments, you can check out our information in the description below, or leave a comment in the comment section. So thanks for watching, and we'll see you on the next one.